All right, you guys, we're going to work the odds of the Chapter 12 review. You should have your formula chart close by you. All right, so for number one, we have a prism, and I know it's a prism because I have a set of parallel bases that are congruent. And the first thing when you hit a prism, the first thing you want to do is identify what your base is. And in this one, anytime you have a rectangular prism or a cube, you can always use whatever it's sitting on. You cannot do that, for example, on number two. Number two, what it's sitting on does not have a parallel and congruent rectangle above it. So you couldn't use that as your base, but what you do have congruent shapes of are the triangles. So I would use the triangle as my base on number two. But back to number one, when you calculate volume, the regular volume formula of a prism is area of the base times the height, capital B times H. And surface area, according to my formula chart, is PH plus 2B. So the first thing I want to do is there are three unknowns in my formula, H, B, and P. H is my height, which means the number that describes the distance between my bases. So if my bases are top and bottom, 9 would be my height. I'm going to go ahead and identify capital B and capital P. Capital B stands for area of the base. When I look at the bottom of the base, this base shape is a rectangle. So if I calculate area of the base with a rectangle, that would be length times width, which is 12 times 22, which comes out to 264 for big B. Now if I calculate P, P stands for the perimeter of the base. Perimeter is always just add up all the sides. So we have 22 plus 12 plus another 22 plus 12. And that comes out to a perimeter of 68. Okay? Once you've got all your pieces, plug into the formula. So for volume, I would want big B, 264, and multiply by my H, which is 9. 264 times 9 comes out to 2376. My units on this are volume would be meters cubed. Surface area, capital P we found to be 68. The H is 9. Plus 2 times big B, which is now 264. Just going to type that in my calculator, which comes out to 1,140. And since surface area is squared, our units here would be meters squared. Looking at number three. Number three, we have a prism again. It is a triangular prism where the triangle is my base because I have two congruent triangles that I can actually trace, right? Those are my bases. So I want to find volume, lateral area, and surface area. The volume formula for a prism is area of the base times the height. The lateral area of a prism is perimeter of the base times the height. And surface area of a prism is perimeter of the base times the height plus 2 area of the base. So I'm looking at each of my formulas so I know what things I need to find first. I'm missing height, base, and perimeter. So when I look at the height is again the distance between your bases. If our bases are triangles, the height in this problem is 9. So 9 is my height. Let's go ahead and calculate capital B. That shape is a triangle for the base. So when I go to the triangular formula, that's base times height of the triangle divided by 2. Base and height always meet at a right angle, so that tells me the base and the height are 5 and 12. So I do 12 times 5 divided by 2, which gives me a capital B of 30. And then for perimeter of the base, I need to add up all the sides. If this hypotenuse was not given, I could do a squared plus b squared equals c squared and solve for it. But the fact that 13 is on that back side means that these two lengths on the triangle have to be the same because they're congruent and parallel. So perimeter, to calculate that, I'm just going to do 13 plus 5 plus 12 add up the sides, which gives me 30, ironically. So now I've got all my unknowns and we can plug back in. To find the volume, big B is 30, the height is 9, so my volume would be 30 times 9, which is 270, and then meters cubed for volume. Lateral area, if I plug in, would be the perimeter, which is 30, times the height, which is 9, which happens to also be 270. However, the units here are different. It is meters squared. And then for surface area, you're taking that perimeter times the height, which is 270, and adding that 2 times the area of the base, which we calculated to be 30. So 270 plus 2 times 30 comes out to 330 meters squared. All right, on to the next page. Number 5, Janet has a circular garden, so I'm going to draw a circle with a radius of 40. So I'm going to put 40 in the middle. She used all of her fencing from the circular garden to enclose a square garden. The length of each side of Janet's square garden was approximately what? Well, here's the deal. We cannot figure out what we have for a perimeter of a garden until we know how much fencing would go around this circle. When you talk about fencing of a circle, that's the circumference formula, where circumference is 2 pi times radius. You will be getting that on your on the test day. If the radius is 40, then I would plug 40 in, and that leaves me 80 times pi feet for my square to use up. I'm going to actually calculate what the decimal value of that is, which is about 251.33. Okay, if that is supposed to be my perimeter of my square, think about how you would find the perimeter of a square. You would add up 4 unknown sides. Sorry, y'all can't see that. There you go. I would add up all 4 sides, which is 4 x's, and set it equal to my perimeter, which is 251.33. So I'm going to divide that evenly by 4 sides, which comes out to about 62.8 feet, which rounded comes to option B, which is about 63 feet. So that means each side is about 63 feet in order for it to match the circumference of that circle. All right, number 7. Number 7's shape is a cone. I know that because it's round on the bottom and it meets at a point. With a cone formula, it wants us to find all 3. So lateral area is pi times the radius times L. Surface area is that number, pi RL plus pi R squared. And the volume, I'll come over to the left, volume is pi R squared H divided by 3. When I look at the unknowns here, I'm missing a radius, a height, and an L. So I need to identify those pieces in my cone. 7 is representing R. 24 is representing H because it's got the right angle. And then L is whatever this side length is out here. Well, when you look at cones and pyramids, you always have this right triangle formed with your height. So we could use Pythagorean theorem to figure out what L is going to be. So I'm going to do, I'll come down here, a squared, which is 24 squared, plus 7 squared equals L squared. 24 squared plus 7 squared is 625 equals L squared. So I'm going to square root both sides, and that gives me L of 25. So I'm going to go ahead and write L equals 25 up there in my picture. Now I'm going to go through and calculate each piece. So lateral area was first. So lateral area would equal pi times my radius, which is 7, times my L, which is 25. Make sure y'all are pulling the right numbers on this part. If I'm leaving this exact, I'm just going to do the 7 times 25 part, which comes out to 175 pi, and then I need to add my units to the end, which would be meters squared. For total area, I'm going to take that 175, oops, 175 pi, and add to that my pi radius squared, which in this case is 7. 7 squared is 49, so I'm going to add that 49 to 175, which comes out to 224. Sorry, my hand's writing whatever it wants. Pi. So total area would be 224 pi meters squared. And then for volume, volume takes the pi, multiplies by the radius squared, which in our case is 7, multiplies by the height, which is 24, divided by 3. So again, on the calculator, I'm just typing in the numbers part. 24 times 7 squared divided by 3 comes out to 392 pi. And then my units for volume would be meters cubed. All right, let's look at number 9. Number 9 is a pyramid problem. Okay, this time we're given a pyramid, and we want to find lateral area, which is PL divided by 2. We want to find surface area, which is PL over 2 plus B, and volume, which is BH divided by 3. The base edge in my picture is 32 meters. And the slant height, which is along the edge, is 20 meters. That's your L. And I'm missing some other pieces of information. Like I need to find the perimeter of the base, I need to find area of the base, and I need to find the height. Well, if this side is 32, that means the other side is also 32, which means that the radius of this circle, or halfway, would be half of 32, which is 16. And now I can use a squared plus b squared equals c squared to find what the missing side would be. So let's call that h. We'll do h squared plus 16 squared equals 20 squared. 20 squared is 400, so this would reduce to h squared plus 256 equals 400. When I subtract 256, that gives me 144. And when I square root, I'm going to get a height of 12. So I know h in my problem is 12. Now I need to find the perimeter of the base. Perimeter of the base is going to be calculated from 32 plus 32 plus 32 plus 32, which is 32 times 4, which comes out to 128. The area of the base is 32 times 32 because it's square. So 32 squared would be 1024. So now I'm going to take this and plug into my formulas. Lateral area P is 128. L is in my picture, which is 20, and then divide by 2. When I multiply that together, I get 1280 meters squared. For the total surface area, I'm going to take that 1280 and add to that the area of the base, which is 1024. And that comes out to 2304 meters squared. And for surface area, I'm going to take the area of the base, which is 1024, multiply by the height of 12, and divide by 3. Which comes out to 4,096 meters cubed. Okay, make sure you guys are plugging the right numbers in. I know it's easy to find them pretty quickly, but make sure they're somewhere that you can quickly identify what goes in. Don't go based off of memory. All right, I'm going to work one more problem and then I'll do a new video. On this last problem, number 11, it's asking us to calculate, we have this cylinder, and it's the net that's shown. And we want to use a ruler and measure the dimension of the cylinder to the nearest inch. Nearest inch means a whole number. So I'm going to take my ruler, look on the inch side, which is going to be the bigger pieces. So we have 0, 1, 2, 3 inches. When I measure this one, I'm going to start with the 0 on one side. It's a little over 3, but it's closer to 3 inches than 4, so I'm going to call that 3 inches. Then I'm going to measure the other side of the rectangle, which is a little over 4, but again, we're rounding to the nearest whole number, which would be 4 inches. And then since these are circles, the most important part of my circles are the radius. So I'm going to measure, we're doing closest centimeter to the nearest inch. You guys, this is probably about 0.1, or sorry, 0.5. It's about half an inch, a little bit more than half an inch. So we're going to go to half an inch. And now we're going to calculate, that's for the radius, by the way, not the diameter. Now we're going to calculate the closest total surface area. For surface area, I need to find the area of this, the area of the other circle, and the area inside here. So to calculate the area of a circle, I want pi r squared, which in our case would be 0.5 squared times pi. That comes out to about 0.785. And because I have two circles, I'm going to multiply that by 2 because this area over here, I'm going to add another 0.785 because that's that circle. And then I want to find the area of this rectangle. That's length times width, which would be 3 times 4, which is an area of 12. So I'm going to add 12 and 0.785, which comes out to about 13.57. That would round up to about 14. So I'm going to call that closest to 15 inches.